So I'm going to review the topics from Module 3 that are going to be on your quiz. So the first thing we talked about is identifying whether or not something was a polynomial. So an expression is a polynomial if every variable contains positive integer exponents. So what we do is we eliminate things. So what that means is there are no variables in denominators, no fractional exponents, no negative exponents, and no roots. So if I look at my first example, we have 8x squared minus 7x plus 7 all over the square root of x. So we actually break two of these. We break the no variable in a denominator and no root. So this is not a polynomial because variable is in denominator of fraction and under a root. If we look at our second example, we have 8x to the fifth minus 3x squared plus x minus 6. And all of our variables contain positive integer exponents, so this one is yes, it is a polynomial. We don't really have to explain our reasoning if the answer is yes. We typically only explain the reasoning if it's no. Next, we want to perform operations with polynomials. So this is addition, subtraction, multiplication, and division. So the first one we have is addition. So we look at what's between the set of parentheses, which is a plus sign. So anytime we're adding two polynomials, we start with the term with the greatest degree and work our way down in exponents. So our first term is 8x to the 6th. That's our greatest degree. There's no other 8x to the 6th, so that's going to be in the answer. Okay. Then I work my way down. So I have a 4x to the 5th. There is no other x to the 5th term, so it stays 4x to the 5th. Then we have a 4x to the 4th and a negative x to the 4th. And because we're adding, we can just combine like terms. So 4x to the 4th minus x to the 4th becomes 3x to the 4th. Then we have a negative 3x cubed, and there's no other x cubed term, so it says negative 3x cubed. Then we have a 2x. Oh, sorry, I skipped the x squared. So we have a 2x squared, which there's no other like term, so it stays 2x squared. Then we have a 2x and a 7x, which combine to give us 9x. And then lastly, we have a negative 7 and a negative 8, which combine to give us negative 15. So a very long addition problem, since there weren't a lot of terms with like terms here. A lot of them were singletons. Next, we have an example of a subtraction problem. So anytime we're subtracting two polynomials, I always distribute the negative into the second set of parentheses first, and I drop the parentheses on the first polynomial. So we have 3x squared minus 6x plus 2. Then it becomes minus 5x squared plus 7x minus 8. Now I can combine like terms similar to an addition problem. So we have 3x squared minus 5x squared, which gives us negative 2x squared. We have negative 6x plus 7x, which gives us x. And 2 minus 8, which is negative 6. This is a completely different answer if I would have just combined like terms by doing 3x squared minus 5x squared, then negative 6x minus 7x, and 2 minus 8. So it is important that you distribute that negative into the second set of parentheses first before combining like terms. Next, we're going to take a look at multiplication. So remember, 2y squared is a single term that we are then distributing to every term inside the parentheses. So when we multiply numbers and we multiply variables. So 2y squared times 9y squared. So 2 times 9 is 18. And when we multiply variables, we add their exponents. So y squared times y squared becomes y to the 4th. Then when we do 2y squared times negative x, there's a negative 1. So we multiply 2 by negative 1 and we get negative 2. There's nothing with the y squared to multiply with, so it stays y squared, and we have our x. And then lastly, we're doing 2y squared times 10. 2 times 10 is 20. And then there's nothing for the y squared to multiply with, so it stays y squared. All right, so next we are multiplying 3x squared minus x minus 1 by 4x minus 3. So a good rule of thumb for something like this is everything in the first set of parentheses multiplies to everything in the second set of parentheses. So it's another type of distributive property. Okay. So first I'm going to take 3x squared and multiply it by 4x. So we multiply 3 by 4 and we get 12. X squared times x, we add the exponents and we get x cubed. Then 3x squared times negative 3 is negative 9x squared. Now we do the same thing with negative x. Negative x times 4x is negative 4x squared. Negative x times negative 3 is positive 3x. Now we do the same thing with negative 1. Negative 1 times 4x is negative 4x, and negative 1 times negative 3 is positive 3. Now that I've distributed, I'm going to go ahead and combine any like term. So 12x cubed doesn't have a like term, so it stays 12x cubed. But I have a negative 9x squared minus 4x squared, which becomes negative 13x squared. And we have a positive 3x minus 4x, which becomes negative x. And then we have our plus 3. Our last example says 5x minus 4y squared. So remember, this is the type of problem that you have to expand, because when we square something, we're multiplying it by itself. So we have 5x minus 4y times 5x minus 4y. Then everything in the first set of parentheses multiplies to everything in the second. So 5x times 5x is going to give us 25x squared. 5x times negative 4y is going to give us negative 20xy. Negative 4y times 5x is another negative 20xy. And then negative 4y times negative 4y becomes positive 16y squared. So my only like terms are the negative 20xy's. So we get 25x squared minus 40xy plus 16y squared. Next, I'm going to take a look at division, and I'm going to use synthetic division here just because it's something I'm more comfortable with. Then I'm going to show you an example of long division. So first, with synthetic division, the number in my box, I'm going to take what we're dividing by, x minus 2, and set it equal to 0, and I'm going to get 2. Then across the top, I'm going to put all of my coefficients. So we have 4x cubed. Then working my way down in exponents, there should be an x squared term, which we don't have, so I put a 0. Then -1 for my x term and 2 for my constant. Bring down my 4. I multiply it by my number in my box, which is 2, so I get 8. I add, going down, 0 plus 8 is 8. Now I multiply again. 8 times 2 is 16. -1 plus 16 is 15. 15 times 2 is 30. 2 plus 30 is 32. So when I'm trying to figure out what my coefficients are, the number on the right side of my dash is my remainder. Directly on the left side is my constant. Then I work my way up in exponents. I have x and x squared. So my answer is 4x squared plus 8x plus 15 plus 32 over what we divided by x minus 2. I'm also going to show you long division because you will be asked to do long division on the quiz as well. So I set it up with my x minus 2 on the outside. Then underneath, I'm going to put 4x cubed plus 0x squared minus x plus 2. So I'm still going to account for that missing x squared term. Okay. So now I want to figure out what do I have to multiply x by to get 4x cubed, which is 4x squared, which I'm then going to multiply by all of x minus 2. It's going to give us 4x cubed minus 8x squared. I'm then going to put this in parentheses so I can subtract it from my polynomial. So 4x cubed minus 4x cubed is 0. Okay. 0x squared minus a negative x squared becomes positive 8x squared. Then I bring down my minus x plus 2. Now, so I can see 4x squared, 4x squared. So far, I'm getting the same answer. Now I do 8x squared divided by x, and we get 8x, which I'm now going to multiply by all of x minus 2, and we're going to get 8x squared minus 16x, which we're going to subtract. The 8x squareds cancel. Negative x minus a negative 16x becomes addition, so -1 plus 16, which is 15x. Then bring down the 2, which again, and then 15x divided by x gives us 15. So if we look at the top, 4x squared plus 8x plus 15, so far it's the exact same answer. When I multiply 15 by all of x minus 2, we get 15x minus 30, which we're then going to subtract. The x's cancel. 2 minus -30 turns into addition, and we get our remainder of 32. I'm not going to rewrite the exact same answer, but it would look exactly like what I put for synthetic. 4x squared plus 8x plus 15 plus our remainder of 32 all over x minus 2. Like I said, you're going to have to be able to do both methods on the quiz. So I wanted to show you an example of doing this problem in both types of division. So next we're going to look at factoring. So our first problem, 8x cubed y minus 6x squared y to the 5th. So this is the type of problem where we're going to factor out a GCF. So you start with your coefficients, the numbers. The number that goes into 8 and 6. And the biggest number that goes into 8 and 6 is 2. Then you move on to the variables, seeing how many they have in common. So I have an x cubed and an x squared. So they have 2 in common, so I have x squared. Then we have y and y to the 5th. They only have 1 in common. So my GCF, in this case, is 2x squared y. Okay. That's going to be in front of our parentheses, and inside is going to be what's left over after we divide everything by our GCF. So 8 divided by 2 is 4. If I take out 2 of the x's, it leaves me with 1. And I took out my 1y, so I don't have anything for the y's. For my second term, negative 6 divided by 2 is negative 3, so minus 3. I took out both of the x's, so I don't have any x's left, and I took out one y, so I'm left with y to the 4th in the parentheses. So a good way to check that you have factored your GCF correctly is that if you were to distribute your GCF back into the parentheses, you should get the polynomial that you started with. Next, we have x squared minus 8x minus 20. So anytime you're factoring a quadratic where the leading coefficient is 1, what you can do is you can find the two numbers that multiply to your constant, which in this case is negative 20, but add to the number in front of x, which in this case is negative 8. So I'm looking for two numbers that multiply to negative 20, but add to negative 8. And in this case, that's a negative 10 and a positive 2. Because negative 10 times 2 is negative 20, but negative 10 plus 2 is negative 8. And you could have put the negative 10 and the positive 2 in the opposite places. So you could have written it as x plus 2, x minus 10. So the order of the parentheses doesn't matter. But what does matter is the sign of the numbers inside. So as long as one of your parentheses is an x minus 10 and the other is an x plus 2, it doesn't matter the order in which you write it in. But what do we do in a case like number 10 where the leading coefficient isn't 1 and there's no GCF? So I have 12x squared minus 13x minus 4. I can't factor out a GCF. So what I'm going to do here is I'm going to use the box method. So inside my box, I have the 12x squared and the negative 4. This time, when I look for my multiples, I have to do 12 times negative 4 first, which is negative 48. So this time, I'm looking for the numbers that multiply to negative 48, but add to negative 13. And I know because the number in front of x is negative, my bigger number of my numbers that are multiplying has to be negative. So I'm going to start with numbers that multiply to 48. I'm going to start with the negative 12 and 4, since those are the numbers we multiplied, which don't add. Then I'm going to do negative 24 and 2, which doesn't work. Negative 3. Negative 48 divided by 3 is negative 16. Negative 16 and a 3. And if I look, negative 16 plus 3 is negative 13. So these are the factors I'm going to use. So I'm going to put negative 16x and 3x in my remaining boxes. And again, I could have easily put the 3x in the top right and the negative 16x in the bottom left. It doesn't matter which box you place them in. Now I'm going to factor out GCFs from each row. So 12x squared and negative 16x have a 4x in common. 3x and negative 4, they don't have any common factors, so we're going to use 1. Sorry, this should be a 4x, not a negative 4x. 4x, and then 1. Now I'm going to do my columns, 12x squared and 3x. They have a 3x in common. And negative 16x and negative 4 have a negative 4 in common. And again, you can check that you've done this correctly because now if I multiply what's outside my boxes, I should get what's inside. So 3x times 4x is 12x squared. Negative 4 times 4x is negative 16x. 3x times 1 is 3x, and negative 4 times 1 is negative 4. So now going across the top, that's one of my parentheses, 3x minus 4. And going down, 4x plus 1 is in my other set of parentheses. And I could have done this the opposite way, 4x plus 1 in my first set of parentheses and 3x minus 4 in the second. So next we have a difference of squares. We have 81z squared minus 16. So both of my terms are perfect squares. So when I factor it, First, I'm going to figure out what numbers multiply to give me those perfect squares. So what times itself is 81z squared? And that's 9z and 9z. And then what times itself is 16? 4 and 4. So in my parentheses, we're going to have 9z minus 4. And the second set of parentheses, 9z plus 4. And again, you could have done this the opposite way of 9z plus 4 and then 9z minus 4. As long as one of them is a plus and one of them is a minus, it doesn't matter the order in which you write it in. Our last example is an example of the sum of cubes. So this time I need to figure out what number cubed gives me each term. So x cubed is x cubed, and then 4 cubed is 16. So you have to take the cube root of a number, not divide it by 3. That's a very important distinction for finding cube roots. Okay. So the formula for the sum of cubes is to add your cube roots. So my first set of parentheses, x plus 4. Okay. Then I want to square my first one, so x squared, minus, I want to multiply my two cube roots together, so 4x, and then plus, and then I want to square my second root, so 4 squared, which is 16. And the quadratic we always end up with for the sum of cubes formula, never factors. So my final answer is a binomial times a trinomial here. Please let me know if there are any questions you have over anything from Module 3.